Okay, girls. I am reading section 1.1. Yep, I am reading section 1.1. And here are the essential questions right here. And here are the vocabulary words: thermal energy, temperature, and heat. All right, here we go. Kinetic and potential energy. What do a soaring soccer ball and the particles that make up hot maple syrup have in common? They all have energy, or the ability to cause change. What type of energy does a moving soccer ball have? Recall that any moving object has kinetic energy. When the athlete in figure 1 kicks the ball and puts it in motion, the ball has kinetic energy. In addition to kinetic energy, when the soccer ball is in the air, it has potential energy. Potential energy is stored energy due to the interaction between two objects. For example, think of Earth as one object and the ball as another. When the ball is in the air, it is attracted to Earth due to gravity. This attraction is called gravitational potential energy. In other words, since the ball has the potential to change, it has potential energy. And the higher the ball is in the air, the greater the potential energy of the ball. You can also recall that the potential energy plus the kinetic energy of a ball is the mechanical energy of the object. When a soccer ball is flying through the air, you could describe the mechanical energy of the ball by describing both its kinetic and potential energy. On the next page, you will read about how the particles that make up maple syrup have energy just like a soaring soccer ball. What is thermal energy? Every solid, liquid, and gas is made up of trillions of tiny particles that are constantly moving. Moving particles make up the books you read, the air you breathe, and the maple syrup you pour on your pancakes. For example, the particles that make up a book or any solid vibrate in place. The particles that make up the air around you or any gas are spread out and move freely and quickly. Because particles are in motion, they have kinetic energy, like the soaring soccer ball in figure 2. The faster particles move, the more kinetic energy they have. The particles that make up matter also have potential energy. Like the interaction between a soccer ball and Earth, particles that make up matter interact with and are attracted to one another. The particles that make up solids usually are held together very closely by attractive forces. The particles that make up a liquid are slightly farther apart than those that make up a solid. And the particles that make up a gas are much more spread out than those that make up either a solid or a liquid. The greater the average distance between particles, the greater the potential energy of the particles. Recall that a flying soccer ball has mechanical energy, energy which is the sum of its potential energy and its kinetic energy. The particles that make up the soccer ball or any material have a similar kind of energy called thermal energy. Thermal energy is the sum of the kinetic energy and the potential energy of the particles that make up a material. Thermal energy describes the energy of the particles that make up a solid, liquid, or a gas. What is temperature? When you think of temperature, you probably think of it as a measurement of how warm or cold something is. However, scientists define temperature in terms of kinetic energy. Average kinetic energy and temperature. The particles that make up the air inside and outside the house in Figure 3 are moving. However, they are not moving at the same speed. The particles in the air in the warm house move faster and have more kinetic energy than those outside on a cold winter evening. Temperature represents the average kinetic energy of the particles that make up a material. The greater the average kinetic energy of particles, the greater the temperature. The temperature of the air inside the house is higher than the temperature of the air outside the house. This is because the particles that make up the air inside the house have greater kinetic energy than those outside. In other words, the particles of air inside the house are moving at a greater average speed than those outside. Thermal energy and temperature. Temperature and thermal energy are related, but they are not the same. For example, as a frozen pond melts, both ice and water are present, and they have the same temperature. Therefore, the particles that make up the ice and the water have the same average kinetic energy or speed. However, the particles that do not have the same thermal energy. This is because the average distance of the particles that make up a liquid, water, and ice are different. The particles that make up the liquid and the solid water have different potential energies and therefore different thermal energies. Measuring temperature. How can you measure temperature? It would be impossible to measure the kinetic energy of individual particles and then calculate their average kinetic energy to determine the temperature. Instead, you can use thermometers, such as the ones in Figure 4, to measure temperature. A common type of thermometer is a Bob thermometer. A Bob thermometer is a glass tube connected to a bulb that contains a liquid such as alcohol. When the temperature of the alcohol increases, the alcohol expands and rises in the glass tube. When the temperature of the alcohol decreases, the alcohol contracts back into the bulb. The height of the alcohol in the tube indicates the temperature. There are other types of thermometers too, such as an electric thermometer. This thermometer measures changes in the resistance of an electric circuit and converts this measurement to a temperature. Temperature scales. You might have seen the temperature in a weather report given in degrees Fahrenheit and degrees Celsius. On the Fahrenheit scale, water freezes at 32 degrees Celsius and boils at 212 degrees Celsius. That's Fahrenheit. On the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. On the Celsius scale, water freezes at 0 degrees and boils at 100 degrees. The Celsius scale is used by scientists worldwide. This is also the scale that's used in the UAE. Scientists also use the Kelvin scale. On the Kelvin scale, water freezes at 273 Kelvin and boils at 373 Kelvin. The lowest possible temperature for any material is 0 Kelvin. This is known as absolute zero. If a material were at 0 K, the particles in the material would not be moving and would no longer have kinetic energy. Scientists have not been able to cool any material to 0 Kelvin. What is heat? Have you ever held a cup of cocoa on a cold day like the girl in Figure 5? When you do, thermal energy moves from the warm cup to your hands. The movement of thermal energy from a warmer object to a cooler object is called heat. Another way to say this is that thermal energy from the cup heats your hands, or the cup is heating your hands. Just as temperature and thermal energy are not the same thing, neither are heat and thermal energy. All objects have thermal energy. However, you heat something when thermal energy transfers from one object to another. The girl in figure 5 heats her hands because thermal energy transfers from the hot cocoa to her hands. The rate at which heating occurs depends on the difference in temperatures between the two objects. The difference in temperatures between the hot cocoa and the air is greater than the difference in temperatures between the hot cocoa and the cup. The hot cocoa heats the air more than it heats the cup. Heating continues until all objects in contact are the same.